Here's an example of a report showing files from the flash file system on Cisco routers and switches. Now these flash files are not discovered using the standard configuration of Enturity. I'm going to show you how extra objects can be defined to represent all manner of different types of concept, and I'm going to use a flash file as an example showing how this can be achieved. There's a MIB called Cisco Flash MIB that defines which flash files are present on Cisco devices, along with details including their size. The standard Enturity license is supplied with support for 20 extra object types, in addition to all the other system objects used to model the standard supported aspects of network devices. In this MIB, there's one table of files for the entire device, and that matches the way these extra objects are intended to be used. Each extra object type has two attributes defined representing the name of each object, instance, and the index into the MIB table from which it's being populated. I'm now on the user-defined polling page, which is available from the administration menu. I'm going to select the Collectors tab. And I'll start by adding a new user-defined collector for the object attribute that holds the index. Note that this is still an object attribute, even though I'm about to define its purpose. I'm therefore going to choose the Object Attributes category and add a new collector. In this case, I'll need to select a suitable Cisco device that has flash files available. The name of the collector isn't really that important, but it'll help keep it understandable if you give it a meaningful name. It's a good idea to add a description to help others who may need to apply changes at a later date, but I'll skip that step for now. The appropriate object should then be chosen from the Object Type menu. In this case, I'm going to be using the first of the extra object types, which is UD Component 01. If it hasn't already been selected by default, the index attribute should be chosen from the attribute menu. The MIB browser is going to be used to locate a suitable OID to perform a MIB table walk to obtain all the entries that will be turned into individual object instances, which, in this example, will represent each and every flash file on the device. If I use the Manage MIBs option to see the list of available MIBs, you'll notice that the Cisco Flash MIB isn't present, but it can be imported through the browser if you have a copy available. Now that I've imported it into the MIB repository on the Enturity server, I can attempt to load it, which causes it to be parsed. In this case, you'll see that the loading was unsuccessful, but a quick look at the results window explains why. It's trying to import another MIB file, which isn't present, so that also needs to be imported into the MIB repository. Now that I've imported the required file, I can try loading the primary MIB again, and it completed successfully this time. You only need to load the primary MIB, as it will import whichever other dependent MIB files are required to complete the job, so long as they're available in the MIB repository on the server. Back in the MIB browser window, I'm going to locate the table that holds the list of files with the aid of the Find feature. I know it contains Flash File Table. Here it is, and it's called Cisco Flash File Table. I'm looking for a small data type, such as an integer or a gauge that I can use to walk the table to derive the index. The file size attribute should be suitable, and I can confirm that it's accessible by reading the first entry in the table using the Get Next button. Every time you click the Get Next button, another entry will be read from the same table. Incidentally, if you'd chosen the Cisco flash file index OID, you'd have found that it wouldn't return any values using getNext, as it's a non-accessible OID. Once I click OK, you'll see that the appropriate OID has been placed in the collector definition, and it's contained in some further syntax in the method statement. Index attributes have to be handled subtly differently to any other type of attribute, as they use an SNMP table walk rather than a simple get operation. I'm going to use the Edit button to apply two changes to this statement. Firstly, I'm going to change the name of the function being called by adding _indexes to the end of its name. Then, the second parameter needs to be modified, as it no longer represents the index, but instead is used to specify the maximum number of entries that will be returned by the table walk. I'm going to use 500 for this example. Index collectors don't use an index themselves, so the index setting should always be set to none. You'll notice down here in the filter statement that as I'd previously selected a Cisco device, the system object ID is being checked to see if it is a Cisco device. This means that unless changes are made, the flash file discovery operation will only be performed on Cisco devices, which is what I want, as this MIB is Cisco proprietary. Everything else can be left with its default settings. That's all the changes that are necessary, so I'll click OK. Assigning a user-defined collector for the name attribute is even simpler, as this is an ordinary attribute, so no changes need to be made to the method syntax. In this case, I'm going to obtain the flash file name from the MIB and use this to identify each file. This is an indexed attribute, so rather than none, I'm going to need to select that index which we've already defined. That will be incorporated in the method syntax. The basic definition of the user-defined object has now been completed, and over the next few minutes, or possibly hours on a system that's already monitoring a large number of devices, the Cisco devices will start to populate a list of flash files, which will be visible in the association's dashboard. You'll notice that the name of the association is still showing its default value, which is UD Components 01. And when I select it, you can see the complete list of flash files on that device. When I select one of the files and select the summary dashboard, you'll see that the object type is listed as UD Component 01. While the display of these default names is okay while the configuration changes are being performed, you'll probably want to change them to a more suitable name at some point. There's a configuration file that defines the extra object types and how they'll be named in the user interface. This file is in the etc directory of the Entuity installation and is called sw-user-defined-components.cfg. As tempting as it might be to make the necessary changes directly to this file, you shouldn't do this, as those changes would be undone when the system is later upgraded. Instead, create a new file in the text editor and copy the definitions of the UD Component 01 type and the UD Components 01 attribute into it. The display names can then be edited to refer to the new role for this object type, something like this. A list of the components would normally be a plural. Now save the file and give it the name SW User Defined Components Site Specific. Then add a suitable line to the end of the SW Site Specific.cfg file. The exclamation mark on the beginning of the line causes the file to be included into the configuration when the whole server is reconfigured. I'm going to save that. Before continuing, any logged in users will need to log out, and you'll need to shut the Entruity server processes down, rerun configure, and then restart it. This can all be done from the command line, and configure can even be told to reuse the previously supplied settings by including the defaults parameter on its command line. I've changed directory to where I've installed the product, and I'm now shutting the ENA server down. The configure utility can be run like this, and the defaults parameter tells it to use exactly the same configuration settings as before. Now the Entruity server can be restarted. Now that the system has been restarted, and I look at the associations on that same device, you'll see that we now have the flash files named appropriately. And the individual file has the object type of flash file.